Hello students, today we are going to discuss about surface tension. What is surface tension? See here, this needle, it rests on the free surface of water. The same way the insects, it moves over the surface. How it is possible? Because the free surface of the liquid, it acts like a stretched membrane and it supports the needle, it supports the insect. So, which property is that? This is surface tension. Surface tension is the property of the liquid by virtue of which the free surface of the liquid behaves like a stretched membrane. Otherwise, the free surface of the liquid has the tendency to minimize its surface area. In detail, we will discuss surface tension. Before that, we will discuss about what are the different forces of attraction between the molecules. Force of cohesion. What is force of cohesion? When you take water in a glass, you know that there is a force of attraction between the water molecules. This is the force of attraction between molecules of same kind. So, this type of force of attraction, that is called force of cohesion. But there is a force of attraction between the tumbler and the water's molecule. So, this is the force of attraction between the molecules of different kinds. So, this is force of addition. So, mainly there are two types of force of attraction between the molecules, that is force of cohesion and force of addition. Force of cohesion means the force of attraction between molecules of same kind, and force of addition means the force of attraction between molecules of different kinds. Now we will see what is meant by molecular range and what is meant by sphere of influence. Here we are going to discuss the cause of surface tension. For that purpose, we should know what is meant by molecular range and sphere of influence. See, what is meant by molecular range? See, when you take a molecule here, and these are the neighboring molecules. See, this molecule as the center, you know that the maximum distance up to which the force of attraction between the molecules exists, that is molecular range. The maximum distance up to which the force of attraction between the molecules exists, that is molecular range. Then what is sphere of influence? If you draw a sphere with the molecule as center and the molecular range as a radius and draw a sphere, then that sphere is called sphere of influence. So we can see here say this is the molecule, and these all molecules are attracted by this one, and this maximum distance, this is the molecular range, and we made a sphere here, so that will be the sphere of influence. So the cause of surface tension we are going to discuss here. So we have to consider the sphere of influence of all the molecules. Now see, here we have taken liquid in a vessel and we marked few molecules here, Q, R, S and P. See, here P is completely inside. So that means all the molecules are attracted equally from all the sides. P, the net force on P is equal to 0. The same way Q is also completely inside. So from all the sides the molecules are equally attracted. Then the net force on Q is 0. Then for R and S, see, for R the major part of the sphere of influence is inside the water. So there is a downward pull. And the same way for S also, the means a minor portion is inside the water. So here also there is a downward pull. So the net force on R and S is not equal to 0. When these molecules are coming to the surface, the molecules has done some work. So this work it has done against the gravitational force. So whatever the work the molecules have done to reach the surface, it is stored as its potential energy. If more molecules are on the liquid surface, that means more will be the potential energy. So more molecules are on the surface, more will be the potential energy. If a system, the potential energy is more, that means the system is unstable. Every system has the tendency to reduce the potential energy. So how it will reduce the potential energy? By decreasing the number of molecules on the surface. So how can it reduce the number of molecules on the surface? By reducing the surface area. So that is why surface tension is the property of the liquid to reduce the surface area. This is the molecular theory behind the cause of surface tension. Now we will see what is meant by surface tension. How can you measure surface tension? See here, this is the free surface of a liquid. Free surface of a liquid, you can see it. Free surface of the liquid. And this free surface, what happened? You know that the free surface of the liquid, it acts like a stretched membrane. We have drawn a imaginary line. We have drawn an imaginary line AB on the free surface of the liquid. Then see the force, it is perpendicular to the imaginary line, and tangential to the liquid surface. So what is surface tension? Surface tension is equal to force upon length. Force upon length. Force upon length. Then what is the force? Force is acting perpendicular to the imaginary line drawn on the free surface of the liquid. This force is acting from both the sides. See here, this is one side and this one is the other. And it is acting tangential to the liquid surface. Tangential to the liquid surface and perpendicular to the imaginary line drawn on the surface. So surface tension is equal to force per unit length, and the same way you have to tell what type of force. Force is perpendicular to the imaginary line drawn on the free surface of the liquid and tangential to the liquid surface. So we can say that force per unit length, that is surface tension. So what is its unit? Its SI unit is, you know that force unit is Newton, and length, that means Newton per meter. Then what is its dimension? Its dimension is, force dimension is M1 L1 T minus 2, you know, then divided by L1. So what we will get? The dimension is equal to M1 L0 T minus 2. This is the dimension. Okay, so this is the how to measure surface tension. Surface tension can measure, that is force upon length. Now you can see the whatever we discussed. So the note, it is given here, so you can see it. Till here we discussed.